Good evening, all. As we are a little over time, without much further ado, let's get started with today's session, Clean Technologies for a Sustainable World. Before we kickstart the session and formally introduce the speaker for today, I would now request Dr. Prashant Mishra, Treasurer IEEE Bangalore Section, and also mentor for IEEE Bangalore Section Industry Committee to go over the opening remarks. Dr. Prashant, over to you.
Yeah, thanks, Chengappa. May I welcome everyone to the first expert lecture series that is being conducted by the industry activities team of IEEE Bangalore section. So we have a very well qualified team this year, and why I say we have a very well qualified team, because first of all the team is quite large, and secondly I think the team has taken up a very important topic to tackle for this year, which we believe is probably one of the topmost priority for nations around the world, and that is how do we reduce the greenhouse gases that is present now. So as part of that, we took up this initiative to probably build an ecosystem around clean technologies for a sustainable world, and that is what our speaker, Dr. Ashok Das, will be touching upon today. But as I was mentioning, this team has directed its efforts to create awareness around this topic of clean technologies, and as part of that, we'll be hosting an expert series, lecture series every month till the month of November. And in the month of November, we will host and organize our Bangalore Technology Conclave, where we'll try to pull in all the lessons that we have learned throughout this period and present it to the larger industry and academic and research ecosystem in a way that they can understand the seriousness of the problem, see what are the latest and the best happening in this field, and typically how everybody can take part in trying to make the world much more sustainable by adopting cleaner technologies. So that is as far the industry activities team's commitment for this year goes. And I hope that you all also get pulled into the larger initiative and help us in whatever way you can. And of course, in that process, let us all learn and cherish what we have to understand and learn from the speakers that we get onboarded every year for the lecture series, every month for the lecture series. So thank you, Chenkappa. Over to you for the formal introduction.
Thank you. Thank you, Dr. Prashant, for those opening remarks and really sharing the thoughts on the theme that we have chosen for this calendar year on fighting global warming and clean tech and how clean technologies can help there. So now it's time to formally invite speaker of today's session, Dr. K Ashok Das, founder CEO SunMoksha, who is having a decades of experience in semiconductor equipment and clean technology that spans across smart microgrids, IoT, renewable energy, smart water, and rural electrification. He received several awards and accolades for these innovations, and it's noteworthy to mention that he developed the first smart village and the first smart island projects in India. Dr. Ashok has been a warrior in combating against global warming for more than a decade, and he would be sharing his thoughts and learnings in this interactive session. So with this brief intro, I hand over the virtual podium to Dr. Ashok Das, and keen on to listen his insights on for today's session. Sir, over to you.
Thank you, Chengappa. Uh, you all have given me the onus of introducing this year's, Industry Connect theme and technology theme. So thank you very much for entrusting me that. And as Prasant said, that this year we really have many warriors in our team, including Narayanan and then Sunil. So many of us have worked in the climate change, and hopefully we will be able to make a difference in the IEEE mission this year with regard to the climate change. So without further delay, let me just get started. So as I said, we will be talking about clean technologies. And, the outline of my presentation today is what is climate change? It's why is it happening? What are the contributions, or what contributes to emissions of GHG into the climate? What are the impacts of climate change? What can we do to mitigate the climate change? And what will be the theme for our this year's BTC 2021? Uh, I don't know how many of you know, but this year this is the temperature that NASA records every year, and they started from 1884, and you can see the way the temperature changes over time. And eventually, this is the current year, and 2020 is the warmest year on record. And it has almost reached about 1 degree above the baseline that we are all trying to strive to be within the +2. By the way, this year also tied with 2016. So 2016 and 20 were almost similar temperatures. IPCC has also continued to record this, and they report that the rise is 1 degree centigrade so far from the pre-industrial levels. So as you may have seen it, the baseline is 1950 to 80. So that is the pre-industrial. After 80, the industrialization started at a very rapid pace. So that you can see the space of rise from 1980s to 2000 is almost 5 to 10 times what it used to be before that. So this space, if at this space, it is likely to reach 1.5 by 2050, and almost 4 to 5 by 20. It should be 2200. Okay, so but what will all lead to? What will happen? Essentially, we have already started seeing many instances of this climate change, whether it is the glacier melts, whether the glacier burst. We are already seeing a lot of water depletion even in the rivers. Many rivers are drying because the glaciers are receding. The agricultural resources are also decreasing. We all know and have seen the air quality of Delhi. Every year it is the same repeat cycle. And even though we do not see directly, but indirectly, actually people in the city always see it, the water crisis. So the water table is really vanishing, and we are into a big mess with regard to water. And perhaps water is going to take much more priority compared to anything else, even energy. You can live without light, but you cannot live without water and food. So food and water are getting impacted heavily, and we really need to do um, something to take care of it. So because it is impacting our lives. So let's say that in 3 decades, if the temperature rises by 2 degrees, that is the +2, the sea levels will really rise. It is 70% of the Earth's coastline will be rising by 0.2 meters. This is all IPCC report. Ocean will become more acidic, so the life within ocean will be impacted. Oxygen level will decrease, and more dead zones will be created. Of course, this is a very doomsday scenario. But let's see what can be done, and it's still a prediction. But we are already seeing the rise in ocean and rise in water level around the world. So it's not that it's not going to happen. These are things that is already in the making, and there are examples of this happening all around us. So what causes it? Essentially, the cause is all the gas that we emit, greenhouse gases. They create a layer around the surface of the earth, and that starts to trap heat. The sun, the heat from sun comes down to the earth. Some gets absorbed, some gets reflected, but from the absorbed one and even the reflected one, some of them just get trapped. And this trapped heat is what is resulting in continuous increase in the green in our temperature. If you look at the cycle, you look at all the arrows, everything is emitting. Industries, household, energy, rigs. There are a lot of energy emitters or greenhouse gas emitters versus the sink. Sink is only two. If you see that coming back is only to the trees or the ocean. So these are the two places where carbon gets absorbed. Otherwise, everywhere else, carbon is getting, or CO2 is getting emitted, which is leading to the cause of this GHG. So as I said, everything, food, transportation, housing, water supply, all of these systems are leading to the increase in the greenhouse gases. If you look at the data, 72% GHG is coming because of energy. The energy use is causing 73% of the GHG rise. Out of that, industries are 24%, transportation is about 16%. The next major emitter is the agriculture, which is very interesting because this is key to our food, and this is leading to a lot of emissions of greenhouse gases. How do we control that and yet provide food and less sustainable agriculture to the world? Of course, the industries are also in that range, industry and waste management. So these are the four major areas that GHG is getting emitted. If you look at the energy density of consumption of energy, definitely the US and the European nations are at the highest level. The energy consumption is very, very high. But even India, Russia, and other European nations are not that far behind. They are the second in line. Sorry, this is China. So Europe, India, etc., are in the same range. America and China are leading the whole race for energy consumption. 25% of energy emission or GHG emission is from China, followed by 12% from US, followed by India. This is very surprising number that we are number 3 in emitting greenhouse gases. Another measure, a better measure though, is per capita emission. If you look at per capita emission, then you will see most of the developed nations are the one which are way, way ahead, way, way higher than the developing nations. If you look at India is way low compared to US, Australia, Canada, even Japan, Germany, etc., right, and the UK. So per capita, and the entire debate in the COP, the Conference of Parties, every year is whether we need to only focus on the net emitters, or we should focus on the emitters per capita based on the per capita, because it also impacts the development. So there are a lot of debate going on, development versus energy consumption versus managing your GHG emissions to the required level, right? Many of developing nations have committed, and they are doing things to reduce the GHG. But I think a lot more needs to be done from the developed nations. If you look at the distribution, again, you will see electricity, electricity, electricity. Every country, electricity and heat is the highest percentage of the contributor to GHG. So energy and and followed by somewhere manufacturing, somewhere transportation. India second is agriculture. But electricity and heat, that is the energy component, is one that is top priority everywhere. The top emitters in every nation, and that gives us some ways that now you would know why we are focusing so much on energy and renewable energy to reduce that dependence and bring that component down drastically. So what can we do? As I mentioned earlier, there are only two things, CO2 sinks, that is the trees and the ocean. So definitely the number one is that we need to increase CO2 absorption, preserve and grow more plants, trees, and forest. Right? The depletion in the forest is one of the key reasons for temperature increase as well, because there is nothing to stop, nothing to absorb the CO2. And that is why temperatures continues to rise. So that is definitely one of the top priorities that the nations worldwide are trying to do, that grow more trees, plant more trees, grow more plants. Then the second thing is that you need to decrease your emissions. And decreasing is not only about mitigating, but also adaptation. So you reduce, reuse, and recycle. That is one of the key mantras for us to achieve this goal. And the third is, of course, we start to use renewable sources which are not non-GHG emitting. So these are the technologies, these are the solutions that fall under the clean technologies. The clean technology is broadly, a diverse range of products, services, and processes that harness renewable energy, renewable materials, and energy sources, reduce the use of natural resource, and cut or eliminate emissions or waste. They are called multiple names: green technology, sustainable technology, etc. And why do we need it? I think by now you all would agree we need to fight, or we need to combat the climate change and global warming, depleting non-renewable sources. Population growth is also causing huge amount of pressure, and increasing living standards are exerting extreme pressures on the resources. And sometimes we say that we are saving the earth, but frankly, we are saving ourselves. Earth has survived many such extinction, and it will survive, but the earthlings will not be there. So it is a fight of survival of the humanities, not about the earth. So that we need to keep in mind. So how do we reduce it? Of course, we can start with there are multiple options, and starting from renewable energy generation, smart grid, energy storage, energy efficiency, sustainable transportation, green buildings, clean materials, carbon capture, clean air, water, and energy conservation, clean production, waste management, sustainable agriculture. These are the vast range of technologies and solutions that can be worked on to eventually reduce the overall emissions. And why? This is just so that this temperature or this image doesn't look any worse, right? We need to stop. We need to bring it towards the blue that we saw in the earlier. We don't know if we will. Of course, Narayan, forget it. We are not going to be, we'll hardly be able to reverse it. If we can keep it under control, that will be a major success. But our goal should be really to reverse it. If you take I'm just showing you a campus, but this can apply to any community. There are so many sustainability measures that we can do along the lines I showed you. that will help reduce GHG emission. Water uses, water supplies, sewage water, wastewater, transportation, energy uses, waste management, food supply, greeneries, all of these contribute to reduction in the greenhouse gas emissions. And as you can see that this is not something that is, in isolation. The technologies and the solutions and the problems are really interrelated. Here is an example that we are doing for the Indian Himalayan region studies. And we think that, forest will be a separate watershed, is water problem is a isolated problem, wildlife is isolated problem, clean energy is isolated problem. We have found that it's not. One of them impact the other. So there is an interdependency of these problems and solutions. You may find a solution in one of the areas, and that may create a problem in another area. So we need to look at things holistically, and we need to look at that what are the impact of any solution that we bring today. If you all remember, we brought solar in the when we started developing solar. The thin film solar came, and then we realized there is a huge problem with recycling. Right? It creates a lot of chemical waste. So now, do we go to that path or we stop? Right? You all use batteries. The use of battery is solving your clean energy problem, but it is creating a lot more other problem, waste management problem. How are we going to recycle it? How are we going to, get rid of the waste or the residual of those chemicals and batteries? So the point here I'm trying to make is that we need to look at things in a holistic perspective. So let's look at some of these technologies. Now, I'm not saying that you will get all the knowledge about what all can we do here. I'm not an expert in all of them. I work in few of those areas. But what I have put together is a framework that there are certain things that can be done. It's just an introduction, and you can always go and explore more. And a lot of information is available. So I will be just giving you a subtle hint and subtle, sort of briefly touch upon these, that what each of them do and what can be done, and what are the opportunities for many of you who are looking for new technologies and opportunities. Let's start with renewable energy generation. The energy is primarily used for the two sectors of electricity and heating. And in the electricity sector, you have multiple options of renewable. And similarly, in the heating, you have multiple options of renewable sources. We'll look at it one by one. So starting with biomass. Biomass can be used in two ways. Actually three ways, right? So it is essentially used to generate either heat or electricity. So in the combustion and gasification route, this is a gasification route, you can get electricity and heat. Biofuels and fuel processing, you can get ethanol and renewable diesel. So these are the liquid fuels to replace diesel and gasoline. And then biomass combustion gives you, it takes you away from coal to generate the same electricity via heat in a steam power plant. So these can be used to reduce the amount of coal being used to produce power. Biogas is a methanation process. So whatever is the food waste, there is a lot of decomposable waste that we generate, and that can be converted into biogas. And it can be used for, best use, of course, is for industrial heating and cooking, but it can also be, and steam for process it, but it can also be used for power production. And recently, you may have talk about big PNG companies or LPG companies coming in and asking us to sell biogas to them. So they're trying to get into a distribution of biogas into our households and to the end users. So that's another big opportunities and big area that is coming up to really make biogas a successful venture or successful technology. We are all aware of the wind, and it ranges from micro, less than 10 kilowatt. In fact, it has gone down to the 2 kilowatt range, all the way up to the megawatts. So megawatt wind turbines, and a lot of development and technologies are still under development. Wind offshore technology is the one that has recently been launched. Then vertical wind turbines. So there are a lot of other development taking place to make wind a success. Hydropower is same way that uh, usually when we talk about hydro, we talk about multi megawatts, thousands of megawatts of power. That has led to a major disaster in these hilly areas where these power plants are, and now it is not considered renewable anymore. All the renewable options are below 100 watt, 100 kilowatt or something. It's a small power plant that can serve smaller communities and not disturb the entire area around that community. Uh, and these lead to the concept of that there should be a microgrid where we can feed such small power and serve a community. Picogrid, Pico Powers, Pico Hydro has been, implemented many places in remote areas to power the communities. Solar energy, we all know, we all see it every day, and there are two major applications, two main outcome. One is thermal, another is photovoltaics. So in the thermal, we use it for heating. We can also use it thermal for electricity by generating steam. And of course, the photovoltaic is converting your solar energy directly to electricity and to the homes and final uses. So let's look at quickly. There are many ways, many developments that have happened on the solar thermal. This is cooking, for process heat, for concentrated steam generator, and for solar water heaters that have become ubiquitous on our rooftops, especially in Bangalore and cold places. Solar thermal, as I said, you can use thermal electricity to generate steam, and that steam is used to generate power. So it's essentially a steam power plant where steam is generated through solar heating. There are multiple technologies available and being used to make that happen. Photovoltaics is the simplest and the easiest sort of, you put the plate in the sun and you get electricity, right? So it all started from small applications like solar lantern, and now we have gone all the way to the megawatt solar power plants where solar parks have been developed to cater to the grid. This change has been very rapid over the last decade or 2 decades, you can say. And it seems now to have stabilized. Of course, there are a lot of development going on in terms of what kind of solar panels, what kind of technology to use to convert the photons into electricity. Microgrids are another, development that has gotten a lot of attention. It has been, it can range all the way from megawatts to a few kilowatts. So this is on the left is a University of San Diego campus where they have 35 megawatt of microgrid to serve some critical loads on the campus. On the right side is like 2 kilowatt providing DC power to many homes just for lighting. And in between comes intermediate microgrids ranging from 20 kilowatts to 500 kilowatts to serve a community with that local generations. So microgrid is nothing but local consumption, local generation, local consumption. It can be connected to the grid like it is here or anywhere, but this cannot be connected to the grid. This is a very small microgrid that is only to be used as a decentralized local usage. Uh, from a related topic is smart grid. So what is a smart grid? A smart grid is essentially to bring efficiency into your generation, transmission, and distribution system. And with more and more decentralized power coming in, solar coming on every rooftop, how do we integrate that into the grid? That is all defined through smart grid. And what is a smart grid? Essentially, it uses analog and digital information and communication technology, gathers the information on the behaviors, and makes decisions as to where to supply what, the electricity, which one to, where, how to manage the load, how to manage my supply, where do I buy it, how do I predict how much solar would I get today so that I can plan my power plant accordingly. So it essentially automates the grid to improve efficiency, reliability, economics, and sustainability of the product. Why? Because it definitely increases reliability. It gives you a lot of flexibility. It brings efficiency, load balancing, and of course, peak load management, differential tariff, and energy trading. So these are some of the things that microgrids allow, smart grids allow you to achieve. We happen to be developing a combination between microgrid and smart grid. So this is some of the technologies that we have developed, which makes the local microgrid smart. So using meters and sensors and IoT, machine to machine, cloud, and several universal protocols to deliver the right quantity of water or energy at the right location, at the right time, and the right price. Uh, as mentioned here, this technology has won many awards from national and international agencies. Energy storage. This is a big topic these days. This is one of the hottest topics. If you look around, everybody's just talking about energy storage, and you will see now more energy storage conference than any other conference these days. So what is energy storage? You can store this energy in many forms: chemical, thermal, mechanical, or electrical. In the chemical is essentially batteries and fuel cells, right? So there are multiple kinds of batteries: lead acid, lithium ion, zinc, sodium flow, and many technologies are being explored to provide the right kind of energy density in the batteries and long life. Fuel cell, essentially hydrogen and methane are the primary drivers for fuel cells. So you have a local chemical storage, you burn the hydrogen with oxygen, you get water, very clean fuel, and you get electricity, right? So no unwanted output or byproduct from that. We have already discussed about steam and oil, the solar thermal technologies. They use molten salt also to store heat, and it can be reused later to generate power. Pumped storage is another option where we are basically pushing water into a reservoir when you have power, and then use it reverse when you need the power. So by storing during daytime, like you have sun, so use the sun energy to pump the water, and in the night, use the water to generate electricity. Compressed air is another technology that has been, being tried and used to store energy. And then the grid scale storage is another major uh, technology area that people are working today. That not only, of course, the grid itself is a big storage for us, right? It takes care of all the fluctuations, but at the grid scale, we also are working on storage technologies to just store the energy so that we can use when the power generation fails. Every technology has a different use pattern, like one of the storage I did not mention there is mechanical, which is flywheel, right? But flywheels work only for a short duration and very high energy density, right? So you can get power, but very short duration. And as you can see, the gasoline are the large is the good energy density and also a specific energy. So you get much more energy per kilogram in gasoline than methane, than hydrogen fuel cells. So there are multiple ways to look at this, and all these technologies are being developed and worked on today. So if you look at some of the data which points that even at least till 2040, coal is going to play a good, a strong role in this coal and oil, right? So natural gas is coming up, but these are the major players. They will still stay the major players for energy generation. Renewable is catching up, and you all know that nuclear is now being abandoned. So whatever is there will stay, but not many more nuclear plants will be created. So all focus needs to move to renewables and natural gas, as you can see here. So still about 33% will be coal. So we are not going to be really getting rid of coal yet, and it's not possible yet. But so that is where um, these are the three scenarios that if we do rapid transition, we can achieve this. If we aim for net zero, then we can go very high. Net zero is rapid plus societal behavior change. This is very important. I will just explain in the next few slides why societal change behavior is so key. And then, of course, business as usual, we were not going to make it, period. This is India. You can see that India moved, coal dependence has gone down from 57 to almost 55%. Not really much. What has happened is that renewables share has increased significantly. So the coal share has gone down. So that is where it comes to energy efficiency. We cannot generate, there is a limitation on generation, so we need to reduce. So energy efficiency helps us reduce the energy consumption. Buildings are the most, maximum number of energy consumption, consumer. Commercial buildings consume, lighting, others, they consume 60%. And in residential also, lighting, fans, etc. So building are major consumption, and there are many ways to reduce building energy consumption. Of course, including solar PV for generation, localized generation, use daylight as much as possible to reduce the use of lighting, and also use natural ventilation, etc., to reduce the use of air conditions. In Bangalore, the air conditions have become so high that air conditioning itself is causing more heat outside, and that requires more air conditioning. So we are getting into a different cycle that we are trapped. So lighting, appliances, and there are energy vampires, some of the things that we all need to do. And fresh air are quite important. The other area is the green buildings. So the whole reducing the footprint of the building is the entire goal. And so it must be bioclimatic, building envelope design, building system design, HVAC, waste management, localized energy, localized material, so that we don't spend too much energy to bring material from outside. These are some of the examples of the green buildings that we have. This is the CII Center in Hyderabad. This is IIT Kanpur. This is Terry Building. And there are many standards available like Griha and LEED. Sustainable transportation, this is one of the major topics, and later we will have more experts talk about the various ways to make transportation sustainable. which includes efficient engines, electric vehicles, biofuels, logistics, mass transit. So if you look at, this scene is, at least every city dweller knows and sees this scene. Uh, so we are really stuck in petroleum and diesel with heavy vehicles, heavy pollution here. Uh, we need better alternatives. And this grid jam is causing really major problem for traffic, right? So this is just to show that how acute the problem is becoming with regard to the traffic. So we need to have, sustainable habitat, integrated residential complex, alternative new technologies, minimize left travel to work, which has happened a lot during the pandemic, but we are still, there is no measure yet that how much it has impacted the GHG emissions, although we could see clear skies in many of the cities where it was not even visible earlier. So it does help. Multiple technologies will come. ICs will still stay one of the mainstreams, and then hybrid, extended EVs, electrical vehicles, and fuel cells are coming up. Will be the choice. This is just another data point to show that motor gasoline, it's it still takes a lot of energy and diesel, whereas compared to today, so majority of the usage is from diesels and gasoline. And again, the same scenario, rapid net zero and business as usual. Business as usual, we will be still heavily dependent on oil unless we move on this path, where electricity becomes the major component of transportation. So, and mass transportation is still the key. Look at if you have 40 cars, 40 people in a car, 40 people in a bus, right? And then to just move, 60 people, to move them, you need so much. And of course, we have our transportation system to move 6,000 people efficiently and fast, right? So we need to really make adjustment to the lifestyle. How do we move from individual transportation to mass transportation efficiently? Waste management, again, you see it all around. And so far, it has been a very centralized approach to waste management. You transport it, you go burn it, you recycle it, you process it, and the whole cycle continues. We need to have a paradigm shift and move to waste disposal. The future will be minimum waste, minimize the waste, and do as much local processing as possible so that landfills are minimized. We need to minimize landfills. We need to minimize central processing. So a lot of recycling and local biogas generation from waste, recycling of papers and plastics. All of these lead to a more sustainable waste management process. And of course, instead of spending energy to dispose the waste, use the waste to generate energy. So a lot of work is, of course, going on utilizing the waste for generating energy and utilizing it into the cities. Industries and materials, obviously, you can see they are one of the major contributors of GHG from two perspectives. They emit and they also absorb a lot of energy. Right? So whatever energy is produced, you would get. So smart production, process improvement, energy efficiency, energy uses, electrical, thermal, all of these need to be worked on. Green supply chain, advanced packaging, water use in the industry is heavy and needs to be minimized. And same for the waste processing. Industry 4.0 is coming. I'm not an expert on that, but I'm just telling you that it looks at economic, environment, and social impact of any process that they do. And that is why we need to move to that more holistic approach to industrialization. Similarly, the design practices need to change. We need to start using the right kind of material from the very beginning. Design such that it is a easier manufacturing, less energy consumption manufacturing, less water consumption manufacturing, and still giving me a quality and durability. Lastly, the agriculture. Water, you may see that the water is, how is water related to energy? You remember, every water that you put out of your tap has been pumped for a long distance to bring to your end location. It requires a lot of energy to pump those water. And if you have leakage, if you have systems that do not conserve water, there is a lot of watergy waste. So we need efficient pump, leak management, automated controls, metering. Close the tap water when not using. Take a short shower, using low flow shower heads. Many gadgets have been devised and are in market to reduce your water usage. Rainwater harvesting is definitely another one that you see that everywhere we are trying to do. Roof water harvesting, roof water to groundwater recharging. Then you use surface water for groundwater recharging, and you use gray water recycle, retreat it, and use it in your fields and to recharge the ground as well. And as one of the cartoonists showed, that if we don't do that, maybe we'll have to finally do this. Wear the umbrella upside down and collect water in our tanks. Can we generate water? You may say that, hey, it is a, can I photocopy the water, and it is a Star Trek replicator where you can generate the water or regenerate the water. But there are technologies now who are working on taking the moisture from air and converting that into water. A lot of efforts are going on in this direction as well. But again, this is not generating water, it's a regenerating and recapturing of the water in the atmosphere. Agriculture has been, as you saw, so almost 17% of energy consumption. So anything we do in agriculture will add a lot of value. So using sensors, AI, ML, irrigation, installation of sensors, minimizing pumped irrigation to minimize energy, use drip irrigation, rainwater harvesting. Many of these technologies are already being used and being pursued. More and more intelligent agriculture is coming into place. And one such solution is, of course, we have also developed one solution to intelligently deliver the water to the field, again, utilizing IoT and cloud technologies, sustainable supply, and sensors and meters to deliver the right quantity of water to the right location, right farmer at the right time. And again, we must use solutions so that we optimize the use of water, not necessarily minimize. We need to optimize, and that happens through technology. These are some of the deployments our technologies have. This is air. So on the air, this image is very familiar to many of you. There are many solutions already being worked on. This is a personal air quality from Bangalore, mapping the entire air quality in the cities so that how to divert your traffic, how to make sure that we use intelligent ways to manage our traffic and manage our flow so that GHG or particulate emissions are less. And then there are technologies that are being used to just clean the air at a large scale. Right? These are clean air filters, which was done in China essentially. That it takes in mass scale, cleans the air. Carbon capture is another technology that is trying to see that whatever carbon is emitted, you just capture it and put it underground. Many technologies are being worked on this area. I'm just showing one or two examples, but this is another hot area that people are working on, developing new technologies. The SDGs, there are certain SDGs also that is aligned to climate change and clean technologies. Of course, the climate action, life below water and life on land is one of the key. The other technologies that are other SDGs that are in the clean tech area are the water 7, 9, 11, 12. So these are all SDGs that climate technologies need to address or are addressing. And that is where you will get this. So this is what we are trying to focus in this effort of Industry Connect's climate technology year to make sure that we have good solutions and good technologies in these sectors being brought in. So that will be the theme for our next BTC, which is in November, which Prashant pointed out. Thank you.
Thank you, Dr. Ashok, for sharing your decade of experience and all the knowledge that you have imbibed fighting, reversing and your focus on reversing the global warming. Now, I would like to open up the floor for questions. So the audiences can also feel free to unmute themselves and ask if there are any questions to Dr. Ashok.
This
Or
is Chandrakant.
probably,
Can I ask a question?
yeah, please, sir, go ahead. Yeah.
Yes, Chandrakant.
Dr. Das, you have put forward in a nutshell what is the problem. Now I have a specific requirement. Say we have a field of, I mean, cultivable field of say maybe 10 acres or something like that. And if I want to have an integrated solution provided by somebody for irrigation of that one, is there any person who can do that? I mean, turnkey sort of solution.
So you just talk to us.
Oh, actually, recently we have put a borewell with the solar pump and all, but these distribution systems and all these things we have not thought about anything. So I was just thinking if it can be enhanced or something like that.
That is our main solution.
Okay,
We
okay,
are
okay.
focusing. We are focusing a lot on irrigation.
Okay,
And
okay. Maybe I'll then be in touch with you on that. Maybe.
yeah. In fact, if
Thank
you
you.
let me see, you needed to see, right? So like this is full automation. This is a big field, right? 270, about 120 acres. This is 20-acre land for a farmer. Again, automation, water management, and including solar, right? So this is in Rwanda, right? Solar irrigation with piped and flexible piping. This again, this is a corporate where we are trying to do for say, what do you say, contract farmers. Right? So yeah, all kinds of work that we have done in the Aquanet. You can see more Aquanet than anything else. Definitely, we'll be able to help you.
Okay, okay. Thank you, Dr. Das. I'll be in touch with you.
Sure.
Uh, Thank you, Ashok sir, for responding to that. So I also request the participants, if you're not able to speak, to drop in your queries in the chat box, or probably as Ashok sir was sharing the details, you could also reach out to him, or probably can get back to us if there are any questions, so that we can connect to Ashok sir offline as well. So well, so again, so if there are any
Definitely.
yeah, thank you, sir. So if there are no more questions for today, we would like to again formally thank Dr. Ashok sir for sharing his insights. I am sure that it would definitely provide a lot of thought process to many of the participants, and they would have many more things to keeping their thinking process in place on most of the ideas shared here on, and probably they would do a bit on reversing the global warming. So with this, we would like to wrap up the session for today. And until we meet again, stay safe, stay healthy, and keep on learning. Thank you all.
Thank you very
Is the
much.
recording available for this, or
Yes, yes, sir. So we would share
yeah,
that with
I
you.
missed
So we
it.
would be up.
I
Yeah,
got late. I was
no
making my
worries.
upma. I was making my upma and I was surprised.
So then you need to ask one question.
Yeah, one question
Okay,
from my side.
I would ask just a simple question. What do you do for the food to stay? What you call the vegetables to stay fresh, even if you do refrigeration? Is
I'm
there a
not a
technology?
refrigeration expert, so I do not know what, to keep it fresh.
Mhm.
I have no idea.
Okay, no problem. Well, we want a startup which will keep the fresh vegetable fresh even if it is refrigerated. Is that
One
After
possible?
refrigeration,
Yeah, after refrigeration, we want to appear fresh again.
the best way to do fresh is buy every day and eat.
Yeah, sure. That is true.
Sorry, but
No, that's right. Absolutely right. No problem. Right.
yeah,
So anyway, I'll hear the recording and then respond back. Thanks a lot.
sure,
Sorry.
no problem.
Yeah, buy every day, buy local.
By
Yes,
yeah, by local, by be vocal, right? Vocal for local.
Local. That also reduces the energy footprint of logistics.
Yeah, carbon
Sure.
footprint. Yeah. Thanks a lot. Sorry for the
thank you. Yeah.
Ashok sir, one
Thanks.
question.
Thanks,
This is
Narayan.
Yogesh.
Yeah.
This is Yogesh. One question I have. Why we do have solar technology has already been improved a lot, and why not in Bangalore or in India we mandate the use of at least one or two solar power cells over the rooftop of every homes and connect them to the grid to improve the power shortage like in India. We do have solar panels for water heater, but can we not have solar panels on every rooftop to improve the electricity over the
Yes,
grid?
yes, we can have. And I think the way when we got, the way we mandated solar thermal for heating was by not giving you a connection, right? There was some requirements. So some regulatory requirement that unless you have this, you will not get your NOC or something like that. Now, for the last decade, there have been so many efforts to, of course, it has been voluntarily asking people and giving incentives and such subsidies to install solar panels. Many have done, many have not. Now, whether it should be made mandatory, at least now the prices have come down. So that, I don't think we have anybody from policy here, but that mandate, that has to be seen how we can make it mandatory and how do you go and enforce it. So the
Can I
best
add to it?
way I still feel is that there is a lot of things that can be done by behavior change, and we need to work on that as well. Regulatory and punishing, or there has to be penalization, right? That's the only way. You are saying that mandatory means you get penalized if you don't do it.
Both ways, like in terms of when they are registering, doing a registration of the property, I think they should make it mandatory that at least they can have a solar panel installed on over the roof or something to
So
contribute towards the grid or something like that.
can I add to it from what I know? So I have a solar panel on my rooftop and I'm talking from Santa Clara, California. We have a net metering which allows us to provide what you call the energy to the grid, and you can buy back at certain rate. Like example, the power rates here are in the range of maybe 30 cents per unit kilowatt. Now, if I supply based on what I have, seven or eight panels per panel, you can get around, let's say, 250 milliwatts and kinds of things. So total turns out to be 2 kVA for me. So the peaks differ from time to time depending on the sun. And so essentially the important factor is net metering. That means if you can connect to the grid without reducing the power factor is usually in the range of 0.995 types. But since you feed in and electricity cannot be preserved through battery, you need to consume it. So the question is, you can't keep charging and putting in anything in your, unless you have an electric vehicle or something, EV or something which you are charging. Otherwise, even then you cannot do a lot of storage of power. Therefore, you have to let it go into the grid. And the grid load balancing is managed at the power stations. And there the issue comes down to, if you have the electricity board of the states, which used to run previously, they used to be very inefficient. But later on, the new power, which is now distribution company, is separated from production company. The consumers have to join into the grid to be able to net meter. So it is not so much about regulatory or mandatory. It is more to do with the ability to manage the grid without failure. And so that means the network analyzer, network management, all that related to power grid has to be efficient enough to manage. All the mandatory stuffs can be overcome by regulation. That's not a big deal. So you give discount of a lot of energy to people, they will start using it. If you find the solar panel is very cheap and easy to install, and plus you have the Googles of this world. In fact, Google and other companies can discount it out because they can get your information more easily. So there is always a scope for it. So given that, I believe it is not just regulatory, it is also the ability of the grids to manage and the ability of the contracts, etc., between the power companies. For like, it should be mandated like 30% or 40% should be solar energy consumption, and that should be state mandated or electricity board mandated. That is fine. That will encourage the industry to participate and bring the solar energy into the houses, and we become the providers rather than just the consumers. So it's a two-way factor for that. That's my understanding. Thanks.
Yeah, thank you, sir.
Look, Tosh, yes,
Ashok,
you have touched it right. Okay, Narayan, you go ahead first.
No, I just wanted, if I could just add something to this. No, please go ahead. Why don't you finish first? And then...
No. You were talking about solar, right? The rooftop?
Yeah, but in general, right? I think the point has to also revolve back, especially take our own community here who are participating, or tech professionals and so on, right? Behavior change is essential, right? Independent of subsidy, independent of getting money back, because the things that Dr. Ashok talked about, 2 degrees C, those are optimistic numbers. That is if we are really good at what we are going to do over the next 20, 30 years, right? And that's a very optimistic number. Now, if we keep waiting for policy, if we keep waiting for subsidies, especially for folks who are able to pay the price for a better future going forward, even the 2 degrees C or 1 degree C is basically a daydreaming activity, right? Having said that, why this lifestyle is so important is because it's, yes, we can have solar grids, we can feed power back, but then there's power, the grid has to be able to deal with all of this. You need to be able to store. There are lots of complications. As part of the energy efficiency, we also have to look at how do we reduce the per capita consumption. So that's why that point is important. Although United States to India, I think the ratio was 14 times or something. India urban and India rural, I'm sure, has a same ratio. Okay.
Yes, I agree.
Okay, so we need to actively, because being privileged part of society in large Indian urban cities, I think rather than looking outside, we also have to look inside. While we look at solar panels for homes, we have had EVs in India for 15 to 20 years. Why is the adoption so low? Although I think there are lakhs of people who will be able to afford EVs even at the current prices. But we just see a small smattering of that, and that I think is a lot to do with not willing to make the lifestyle changes necessary, and a lot of this is that also. While tech can address some of these things, our personal lifestyle consumption patterns in every aspect has to change. Tech can only address a piece of it. The
Yeah,
biggest
and
piece is between
yeah,
between our
and I think go ahead, go ahead.
yeah, no, that's all.
And I think Prakash is in uh, one of the states which is a leader in lifestyle adjustments, etc., and trying to understand what the requirements are. California has always been a leader in many things. So Prakash, you are right that regulation is one, but technical component is also required. And today, if you so the problem here is also the unreliability of the grid. You have the grid connected, but if the grid is not there, where is it going to be feeding to? So many times it comes into that situation as well, right? That the grid is not there at all to feed into. That is one. And the second is of definitely, I don't think our grids are as resilient that the grid has been created in California, etc., or US. So the resiliency in the grid is not, you see, the status of, how much renewables they can really take. Right? So some of these things definitely need to be addressed. Everywhere we have introduced net metering, right? Many of the commercial customers are opting for it. They are doing net metering. Every state, again, it's a state policy. So different states are coming up in implementing net metering policies. So yes, we are there, but I think Narayan has hit the nail on the head that it's us as well. We need to be aware and try to do something.
Agreed. Yeah, there is plenty to go around. Obviously, people who have resources should uh, do something of that kind. And there is a whole gamut of things which has gone through. I think I read the power generation report. It was last year the government had put out, and I went through it. I had certain suggestions also on that net metering types. But I can tell you that it is, so one is the availability of solar cell. There is plenty. In fact, most of the ports, Adani ports and all those, wherever that Kandla and whether you go Chennai or you go towards the Bengal, all of these people use a lot of solar. And even on the, you see all on the waterways, they have put solar all around it. So the generation of solar and its use has to be within. So maybe societies can form together a uniform so that somebody produces, somebody consumes. Or one society with one industry, because industry pattern and society pattern are different. And so load balancing is a big issue here. Unless if grid fails, still you should be able to circulate within that so that the power factor is maintained. That's one of the, because otherwise, if I remember correctly, the voltage, frequency fluctuation, stabilizer, all these are part of the regular Indian power grid. So it's a challenge, it's a challenge. Even California, you talk about big thing, they could not do sometimes whenever there is a load shedding or there is an earthquake or something, they cannot really, the Canadian and the US grids are connected, but they are not able to manage it. Entire things have to be shut down because of some water flooding or something, and it may short circuit people. So you have challenges everywhere. It is there. Reliability of grid is the most important thing before we can really leverage it to the extent we want. Thanks.
Just so as you are aware, now what you discussed is essentially a microgrid. Okay? In the urban setting, in the even if there is no grid, I can circulate that energy within my own community, and a lot of people are now microgrid started from the rural, and that is what we have been doing a lot. But microgrid is now coming to urban. And if you recall the recent crisis in California, that everybody wanted to buy a solar, backup system, right? Because of the grid problems. Uh, a lot of, in fact, California went ahead and passed a bill on the microgrids, right? Very nice policy has been formulated. So I wish those policies are replicated everywhere. But microgrids, for any residential campus here, microgrid would work well. But I'll also give you an example that today, I live in a campus which is 18 floors each building, right? So the number of occupants are so large and the roof area available is so less. We couldn't do much. We tried, right? I tried in our complex. All we said that, okay, whatever roof we have, let's create that solar, and whatever we can do the common uses, let's do common uses. Because it's not possible to support this kind of energy and this intensity with the local generation. The energy intensity has become too high, and that needs to be addressed. How do we address the energy intensity?
There is a solution to it. I had spoken to one of the NASA guys here, one of them who produces the micro cells. What they say is you can have tiles in the building which can be solar capable. And so there is a industry which is, I have not followed up because of the COVID-19. In December of 2019, I spoke to a person who said that microgrid, as you mentioned, is common, and tile-based implementation of solar collection is more popular. And they were trying to, of course, this is all research work. So I said that why don't you produce the tiles in India so that Indians can use it? And I think that was 2019.
At one time, Prakash, BIPV, Building Integrated PV, was hot topic. They have all dropped it. You don't see anybody talking about it because it is inefficient. It cannot serve the whole purpose. Okay?
No, yeah, I get your point.
The tile-based is also, the kind of the solar cells that you use. They're so low efficiency. You really cannot get much out of it. So these still need to be made affordable and mainstream, which is not there yet.
No. So this is where we were discussing, because the US Defense, the DoD, had invested into it, and the efficiency had to be increased to 25 to 28, 30% types. There are some efficiency gains and all they were showing. And this is where I forget the name of the person who I had connected. I'll try reconnect to him because he was very excited. He wanted to do it, something in India. And at that time, I don't know, I lost touch because of this COVID. But I can tell you, there is technology and there are, of course, patents and there are things. But essentially, one can definitely source the people and then try to see that if there is anything available in public or open, because funding, NSF funding is here for all this research, and they were doing some research. I'll connect back and get back later, but there is a solution to it. Yeah, there is a scope for it, for industry to develop based on that, a microgrid, and definitely look into that. Thanks.
Sure. Thank you.
Thank you, Prakash. Thank you for sharing some more insights and picking up on our brain. And it was, in fact, a great discussions and insights shared by Narayanan sir and Ashok Das sir as well. So probably I think we do have a good traction, and keep looking for the notices for our next webinars in this clean tech series. I think going forward this year, we would be having deep dive sessions on many of the topics which Ashok has shared in this session today. So as we are almost top of the hour, in fact, like exceeded the time. So in the interest of the time of other participants as well, we would be wrapping up today's session. So as I said earlier, until we meet again, stay safe, stay healthy, and keep on learning. Thank you all.
Thank you. Thank
Thank
you.
you.
Thanks,
Thank you,
everyone.
Ashok. Thanks.
Thanks, Narayan, for pitching in. Yeah. Bye.